Welcome to aminacademy.com. In strength of materials, let us discuss about springs. Some introduction. A spring is a device consisting of elastic but largely rigid material, typically metals, bent or molded into a form of especially coil that can return into shape after being compressed or extended. Spring can store energy when compressed or extended. In everyday life, use the term often refers to coil springs, but there are many different springs designs. Modern springs are typically manufactured from spring steels. Springs are the elastic bodies which absorbs energy due to resilience. The absorbed energy may be released as and when required. A spring which is capable of absorbing the greatest amount of energy from the given stress without getting permanently distorted is known as the best springs. That means after releasing the load, the spring comes to its original position, then springs are best springs. The two important types of springs are helical springs and laminated or leaf springs. Now we'll discuss further about types of springs. The most common way to classify the spring is by how the load is applied to them. These are the most common classification of the springs. Compression spring. Designed to operate with the compressive loads found in shock absorbers, spring mattresses, mechanical pencils, and retractable pens. Extension springs designed to operate with a tensile load, and archetypical examples is in a slinky, but extension springs are also found in luggage scales and garage door mechanisms. Torsion springs designed to operate with torque, that is twisting force. These springs power every clothespin and mouse straps, that is everywhere. Mostly use the torsion springs. Here, look at this. These are some torsion springs. This is what tensile springs. These are compressive springs. These are torque springs. With each of these, with the, within each of these different springs types, further characterization of classifications. Next, let us look the relationship between the force applied to a spring and its resulting displacement. Again, there are three classes of springs: linear, constant, that is constant rate springs, variable rate springs, and constant force springs. Now, linear springs. Linear springs obey Hooke's law, that is F equal to minus kx, which means that the force needed to extend or compress such a spring by distance x is proportional to the distance, that is Hooke's law, as long as the force does not exceed the elastic limit of the springs. Within the elastic limit of the spring material, this force is directly proportional to minus kx. The Hooke's law is F equal minus k into x, where x equal to distance or L2 minus L1, that final distance, final length minus initial length, where F is a force needed to extend or compress the spring, x distances, k equal to spring constant or spring rate. The negative sign is present in Hooke's law because the restoring force is in the opposite direction. Means we are compressing, the load is downward when compression. The same time, spring gives a negative load about opposite to applied load. That is why now minus sign. Pulling a spring down will cause the downward extension, but the resultant force is upward. Look at here. Suppose compression load is here, it's withstand this. This load is opposite direction. Resultant is opposite direction. The torsion springs obey the analogous version of Hooke's law, that is F equal to k theta. Here instead of x we are using theta, where theta is an angle. In both cases, k is the spring rate and it stays constant no matter the spring's deflection. This is why linear springs are also known as constant rate springs. Hooke's law here is for torsion spring is F equal to minus k theta, where theta is the angle of deflection. Variable rate springs. On the other hand, the variable rate springs does not have the same spring rate throughout its axial length. In other terms, k is not constant. You can have a progressive change in the spring rate or a more abrupt changes. See the diagram. Here is a constant rate, this is a variable rate. Here this extension is different in different length, and this is a firm rate and this is a soft rate. A familiar variable rate spring is the cone-shaped compression springs, most commonly found in battery boxes. The fully compressed length height can be as low as 1 wire diameter. That means that it's completely compressed in a flat. Variable rate springs also have the additional benefit of being laterally stable and less prone to buckling. There are some additional resources for conical springs calculations, that is stiffness and allowable working stress. We will do in later videos. Here, these are some examples of uh, some different types of springs here. Constant force springs. Constant force springs are uniquely formed with retensioned metal strips, not wire as standard springs are formed from. Self-explanatory by its name, the constant force spring requires nearly the same force no matter how long the extensions. Constant force springs are also called clock springs. This type of springs is usually coiled ribbon of spring steel used in counterbalancing applications such as height adjustment for monitors, or you guess it, the clocks. Clock spring is a flat spiral springs. Also, the term constant force spring is a little misleading. The reality is that the spring's full load must be overcome by extending the springs to 125% of the original diameter. Now, this is some usage of springs in door stop or some other applications. Manufacturing springs. Springs can also be classified by how they are made, because there are many methods for making springs. The most commonly known is probably a metal coil spring, also known as a helical springs, but there are many other types of springs. Even an elastic band can be considered as a variable rate springs since it stores mechanical energy. Now, coil springs. The lightweight coil springs are made by forming metal wires on a CNC coiling machines. The multi-axis CNC control allows you to create a variable pitches and end conditions only limited by your imaginations. Flat springs. Flat springs come in all sizes and shapes. Springs washers, PCB spring contacts, and retainer clips are all examples of the flat springs. These springs are essentially sheet metal parts made by stamping. However, there are coiled flat springs as well, such as clock springs and volute springs. And all flat springs need to heat treated for its shape and durability. That is shape memory. that is applied load is released, it comes to original position easily. Now a leaf spring. In a simple form of leaf spring commonly used for suspension in wheeled vehicles, heavy vehicles, originally coiled and laminated or garage spring. Thus, and sometimes referred to as a elliptical spring or cart spring. It is one of the oldest forms of vehicle suspensions. A leaf spring is one of the more narrow arc shaped thin plates that are attached to the axle and chassis in a way that allows the leaf springs to flex vertically in response to irregularities in the road surfaces. Lateral leaf springs are the most commonly used arrangements, running the length of the vehicles and mounted perpendicular to the wheel axle, but numerous examples of transverse leaf springs exist as well. Here, the heavy vehicles fully loaded, that is loaded, that load is transferred to the flat springs and suspension is good. Leaf springs can serve multiple suspension functions, locations, springing, and to some extent damping as well. Through the internal friction, however, this friction is not as well controlled, resulting in tension and irregular suspension motion. For this reason, some manufacturers have used mono-leaf springs. Here, that leaf springs are mostly used in vehicles, mostly in heavy vehicles. Disc spring, belly washers, and conical springs are both common terms used in exchange for disc springs, which are disc shaped with the concave surfaces. They are typically made by stamping, plasma cutting, or blanking a flat sheet of metals. Then the concave shape is typically machined for plate spring. Disc springs can look like deformed metal washers, but they are serve much more complex purposes. Next is machined springs. Machine springs and die springs are used for heavy duty applications with high strength and precision requirements. As the name suggests, machine springs are made on CNC lathes and mills. Molded springs. Plastic or composite springs are commonly found in corrosive environments such as food production, medical, and marine applications. Due to creep susceptibility, they should only be used in intermittent cycles. Compared to metal springs, plastic springs are relative newcomers to the space and supply is not abundant. Some particular uses is there. Source of spring. Now that you know more about the types of springs, it's time to try some out. That means coil springs and certain type of flat springs are widely available in a range of stock sizes and materials that will likely suit your applications. When sourcing, be sure to specify your spring material. Here are some of the most common springs materials. Beryllium copper alloy. Mostly alloy is used for manufacturing springs. Ceramics. One directional glass fiber composite materials. Rubber, urethane, and steel alloys. So far we discussed about what is spring and how it's work, as well as type of springs, how it's manufactured. These are the some information about springs. In further videos, we'll discuss about its strength and design. We have done. Please subscribe our YouTube channel.